Welcome to Lambda Expressions. This is going to be a build-up from what we've already covered in previous sessions. In the inner class, we have local class and anonymous class. And in the story of Lambda Expressions, or in the story of understanding Lambda Expressions, I will be walking us from the top, from local class to anonymous class, and to how we get to have Lambda Expressions for more concise code. So you'll be looking at, in the demo, a social networking application, part of the code. And part of the code for the said social networking application requires us to set up people or members with particular criteria that an administrator could be targeting. So in all the code, throughout the code, we'll just be looking at examples of the criteria for the said members who will be represented by a person class or a person plain old Java object. So I'll just switch to my IDE. This code is available in GitHub. If you're new here, you can find the link in the description. So this is class person. And in class person, from the top, we have enum. And we'll talk more about enum in an upcoming session. So enum is usually used in Java to represent things like, male, female, stack of cards, and such and such. So more about that later. Then we have the fields, name, birthday, gender, email address, and the constructor. And that constructor is initializing the name, birthday, gender, and email address. We have a getter that is supposed to return the age as an integer. Within the getter, there is a birthday. So this birthday that was put in from the creation of the object. Then on that birthday, we are using until and fetching the ISO chronology of that date, birthday instance up to the current date, and then we are representing it in years. But a simpler way to do it, as you'll see in the code, so you can just comment out the previous one, the previous lines of code if you find that they're too much for you, like that. Then you just use this one, which is more simpler, more concise, which is the period between the birthday date, the local date, and it's going to return the years. So whichever the case, the end result is the same. So I wanted to demonstrate that so you'd know that it is possible for us to use the code that I'll be sharing and find better ways of having the same code, or the code that does the same thing in a more concise way, or in a more practical and functional way. So feel free to do that. You can always work with AI and the likes for that. Okay, so more methods in our person. There's the print person. We'll use this a lot also. Then there are others that we won't really use. Matter of fact, I should just remove them because I don't think we won't be using these. But let me not do that because I am working with a source code from the official documentation as per this link. So I'll leave them as they are so they could always represent what's there in the official documentation. So there's the other getters and other things. The one that we'll also use is this one, create roster. So we'll use this create roster to fetch the roster of the person of the people. Okay, let me just say of the person because the class we are working with is person. But anyway, yeah, we're fetching different persons as per the roster. So we'll get to see how we are gonna use this in the next Lambda expression class. So I'll start from the top. Walk with me, please. Then together we are going to create or rather learn Lambda expressions and why and when to use them. So from the top, now what we wanted to do is, as an administrator of the app, you want to fetch users that meet a particular criteria. So we are searching for members that meet a particular criteria. From the top, we would like the criteria that is older than a particular number. So we are saying print persons older than, it's a static void method. The return statement is not required, but then it has two parameters, meaning that if we use it, it's going to expect two arguments. So there's the roster that is gonna fetch this later on. Then there's the int age. So it expects a roster, which is a list of people. We'll talk more about collections later. And it expects an age. Now within the method, what happens is it's gonna iterate through the roster for every person instance. And then if the person, which is this P right here, if we work with getAge from this person class, which is this one, if we fetch a person and work with getAge to get their age, and if we find that it's greater than or equal to the age that will be passed in when we are calling that method, then we can print person, and print person is right here. So print person is just supposed to fetch their name, the place in a comma, and their age. So let's see how we can use that. I'll comment out this main method and see. So we are calling print person older than this method here. We are passing in, as it expects, a roster, which is a list of person, and that roster is this create roster class. Now I'd like to remind us a few concepts that we've already covered. This is a static method, okay? It belongs to the class. What we learned about static methods earlier on is that when you are accessing them, since they belong to the class, you don't go through the instance of the class. Because if I were to go through the instance of the class, I'd need to work with new, I'll need parentheses here, I'll need to initialize the constructor. So it's a static method, meaning I can access it as I am doing right here using just the class name and the dot operator. In a previous session, when I was walking us through that, I mentioned that that is the way you can tell apart the static method from an instance method, okay? So I can just work with person and call create roster. What it should do is to return the roster. And the roster will have these 4 members here, Bob, George, Jane, and Fred, with their different specifications. And then I'm passing in 20. So from within this method that I am calling in the main method, what should happen is the roster that I've passed in will be iterated for every person. And then it will fetch the age and check if it's greater than or equal to 20 as I have passed in, and then it will print. So looking at the person class, I have 1980, 1990, 1991, and 2000. Counting the current date, the current year, which is 2025, then I should get results accordingly. So let me run this and see what that will give me. We are seeing that all of them are above the age of 20. Makes sense because the youngest person we have here is Bob, and they were born in 2000. We're in the year 2025 currently while I'm recording this, so obviously that is above the age of 20. And there we go. So we're just starting simple. We're gonna build on this concept. Now, this is our, let's assume that that is where we're starting. We are starting with, we are starting with the need to fetch a person based off an age or greater than or equal to a particular age, which is 20. Okay. Now there's an issue with that approach. Okay. If you want members below a certain age, what do you do then? Would you need to create another method and work with members below a certain age, or what you can do is to work with a range. If you're sticking to age and you want to work with lower and greater than, you can consider working with a range. So let's build on that. So here's a range method. Print persons within a range. Let me comment out this main method. I made a point of separating the main methods so we can have a one story that flows, but this is for the purpose of learning and purpose of demonstration only. There are better ways to do this. You can have your main class with your main method there and have all of the implementation for the main methods there. Okay. Anyway, for the purpose of learning, so we have this method here. It is accepting a roster as the one before, and then low and high range of age or rather low and high age. Then within it, it's going to iterate through the roster and see if the low value passed in is less than or equal to the age, and if the age is less than or equal to the high range, and it's supposed to print the person by their name and their age. So in this main method, where we are calling that print person within age range, we are passing in our roster. I've already demonstrated or explained that. Then the low is 14 and the high is 30. So what we would expect is to see the name and the age of the person between that range. If I run this, I expect to see Bob 24. Everybody else is above the high of 30. So there we go. Now, another issue with this approach, although we've improved on our criteria, is that we might need to have more such criteria. We might need to have criteria based off gender, based off location, based off relationship status, among others. So what do we do then? Do we create separate methods or what? What could happen is we can decide to work with a local class. So we've already learned local classes. Again, our story here is building towards Lambda expressions. With our local class example, I'll start by talking about an interface. We'll talk more about interfaces later. If you're coming from a background where you've already done programming, then you probably already know what an interface is. If not, bear with me. Interfaces will be discussed in a later session. So we have interface check person. It has one method that needs to be implemented, an abstract method. This kind of interface, we call it the functional interface. Again, bear with me, we'll talk more about interfaces later. But for the sake of our discussion right now, so we have an interface check person. It has one method, test. And this method has a return type, boolean, which is true or false. It is taken in one parameter, person P. So if I were to go to my local class here, which is a class within a method, so we have local class check person eligible for selective service. It's implementing the check person interface. So within the class, it has to override the method. So it's overriding the test method. So that's our local class. Then we are calling the method print person and passing in our roster as it expects. Then we are passing in an instance of our local class, which is acceptable because this local class is implementing check person. So the method initially expects the interface, but when you're passing an argument, it's accepting an instance of our local class because that local class is implementing the interface. So within that, it's just gonna do the same thing, it's going to fetch the test method, and if that evaluates to true, this return statement here, then it will print the person. So it's only gonna print the person who's in the roster, whose specifications for the gender and the age range evaluates to true. If I run this, I expect to see Bob. Yeah, Bob is the person who is male and within the range from our roster. We'll talk more about collections later, so maybe the list here will make more sense after. But if you're coming from a different programming language, you probably already know about lists and any other collections. So here we go. I'll just comment this out. That is a local class and how we could use it. Okay. Now, when we were talking about local classes, I went ahead and I talked about anonymous classes too. So if you would wish to make your code more concise, then you can work with an anonymous class, because the issue is for every criteria, you would need an interface and a local class. So if you would need to make your code more concise, you can work with an anonymous class. Let's see how. So there are two examples for the anonymous class that I have. Let me just, sorry. Let me remove the comments on this one and on this and on these braces here to remove the errors. So the first example is, remember, anonymous class is a class that does not have a name. It just has the body of the class, okay? It's more concise because I don't need to create the whole class definition. So one way to do it is to create an object from checkPerson like this, and then you put in your anonymous class after with the specifications of the overridden method as such, very similar to how you would do it for a local class. And then after that, you'd pass in the requirements for print person unknown, which is a roster and a tester interface initialization like this. Okay. Now, that is one way of doing it. If you would wish, you can go on with that. But then I'll stick to this other method because it's more similar to a Lambda function. So the second way to do it is to actually just call on the method print person unknown, pass in your roster. Sorry, seems like I forgot something here. Let me just check on that. There you go. Okay, fixed it. All right, so the second way to do it is to work with this where you just call the method directly, print person unknowns. It's expecting a roster and it's expecting an instance of check person. So new check person, and then you pass in the unknown class right there. And then remember, with an unknown class, you'd also need to still, because we're within this method, the arguments of this method will still lead to end our statement with a semicolon. So there we go. This is anonymous class. It's gonna do the same thing. If I was to run this main method, I should say Bob24 as I did in the local class. There you go. Okay, now I'll comment this out so we can proceed to the Lambda function. So please take note of this unknown class right here. Lambda function will be pretty similar to it. Okay, so anonymous class is bulky, of course, if it's just gonna be one method. So to make your code even more concise, you can use a Lambda expression. And this right here is our discussion on the Lambda expression. So instead of, oops, let me comment this out, sorry. Comment this out and comment this out. So instead of having this, and I'll select the code to show you. We are calling our method print person unknown, or rather we were calling our method print person unknown. It was expecting a roster and an instance to our interface, and it's the said instance being an anonymous class attached to it. Then it had overridden our tests method, which is an implementation of our interface, right? Now, a better way to do it, or a more concise way to do it, is to just pass in a Lambda function, as we are seeing here. So the roster is still there, right? And then, because now I'm working with persons Lambda, and then when in the area where we are expecting an instance, I'm passing in a Lambda function. So in Java, a Lambda expression implements a functional instance. You do not have to explicitly have an interface there. I will show us in a few. But before I do, let me walk us through the syntax of a Lambda function. So the syntax of a Lambda function is parameters, which in this case is person, the arrow, then the body or the statements, depends. So we are saying that the body here is as we had it in the unknown class and in the local class. The body is, here we go, it's just a single statement. I did that to show us it's a single statement of checking if the person's gender is male and if they're within this range of age. So again, I expect to see Bob 24, but I have fetched Bob 24 in a more concise way than when working with an unknown class, because I passed in a Lambda function, which usually implements an interface. So let's stick to this statement I said earlier. You do not always have to explicitly create your functional interface. Sometimes you can work with a standard functional interface from Java util function. For example, there is a class called interface predicate. So instead of working with check person interface, what you can do instead is work with a pre-existing standard interface from the official documentation, which I also have attached as part of the code in GitHub. You can look at it some more later on. So if I was to parameterize this like I have in our code, or if you were to parameterize it, then in predicate you'd pass in person, because that's the class you're working with. And in Boolean test, you'd pass in, or you'd put the parameters as person t. So the way you would use it then with your Lambda function is put in your roster here and put in predicate person tester as the parameter. So instead of check person, okay? So in your code, you won't need to include the interface, the functional interface, because you'll be working with the standard one from Java util functions. And here we go. So we're still doing what we've been doing, iterate through the roster, check if the Boolean condition has been met, and print person if so. So how do we use this? I'll comment out that main method. Oops, I forgot to comment out the previous one. So I'll just navigate there and comment it out. Then I'll show you. So we are calling on print person with predicate. It's expecting our roster, and it's expecting an interface here, but Lambda function can work there because it's always implementing an interface. So here we go. P get gender as we've done. It's a statement. So as we've done before. So there we go. Single statement. The parameter, the arrow, and the statement. Okay. So that should work. Bob 24. Now, there are many other ways or many other interfaces that you can work with aside from predicate. So because I wanted us to have a further understanding of the said ways, and I also wanted us to have some more practice, I included them in the code. As if you were to stop at this point, you would have already understood Lambda functions, but there's another discussion coming up, a very short discussion coming up. But if you'd wish to know more, you can look at this code, look at consumer interface that can be used like this for the same example. And remember to comment out accordingly so you don't see errors in your code when you're trying it out, because there's this main method here that works with the consumer interface, which you can parameterize accordingly. There's also another one, the function interface. We'll talk more about mapping later, but yeah, there's also another interface. You can comment out your main method. There's also another one that just deals with generics. Again, we'll talk more about generics later because I want to avoid information overload. That's why I'm leaving this for like your self-test, self-assignment. If you find it interesting, you can look at it at your own time some more. If you would rather wait, then you can wait for us until the points where we get to discuss interface and generics for them to make much more sense to you. I don't want to give everybody information overload, so I'll leave it at that, and then I'll go back to the demo, sorry, to the whiteboard to talk some more about this. So here's the story so far. From the top, we were trying to have a search criteria. So let me just go here. We were trying to have a search criteria for the people, the persons, members, okay? We started with age. Let me go back here. We started with age, a single age. We went to a range of age. Then we decided to go for a local class so we can include more criteria like the gender. In this case, it was male. Then we proceeded on to, of course, with our local class, we worked with our interface, yeah. Then we proceeded on to checking out anonymous classes, better way to do, a more concise way to work with than our local class. Then from the anonymous class, we saw how we can make it even more concise by working with a Lambda function, which is an implementation of a functional interface. More on functional interfaces and interface in general. So I'll just go back here and walk us through the syntax once again in case you missed it. The syntax of the Lambda function is the parameters, the arrow token, then the body. So the body so far in our example has been a single expression, but it can also be a statement block. If it is a statement block, it must be enclosed in curly braces. So let's walk through that. First off, for the parameters, you can have the data type, i.e. person P, okay, enclosed in parentheses. The parenthesis is optional if it's just one parameter. If it's more than one, as we'll see in the calculator example, it's required. Then if it is absent, if the target data type is absent, if the data type is absent, then the type of data will be determined by the target type. So it will look at what's happening on the right to know what data type could be possibly could work here. And sometimes if it's in the case of what is expected to be passed into a method, then it will look at what the data type that was part of that method, if applicable. So here we go. Then the curly braces, they are optional, but they are required for statements. For example, for a return statement such as this, you have to include the curly braces. So I'll go and walk us through the calculator example here. It's a class, the class declaration is there. It has an interface whose return type, whose name, is integer math. And within it, there is a method that needs to be implemented, method operation. And there is a method here within the class, operate binary. And what it's doing is it's taking two integers and it's also taking integer math instance. And within it, it's fetching operation from integer math and passing in the values of A, B. So if you are to implement this using Lambda functions, we can have such a simple example. It's a very simple example, by the way, but it's just to show you more functionalities you can have. We can have integer math here, and we are giving it the name addition, and inside it, we're passing in a Lambda function. Remember, a Lambda function is an implementation of an interface. You don't necessarily need to explicitly have it in your code. Java knows how to do it for us in the background. So this is acceptable, okay? So we have A, B in parentheses, the arrow, and the addition. For subtraction, AB in parentheses, the arrow, then the minuses, the subtraction. So if I was to remove this parenthesis just to demonstrate that it is required for more than one parameter, you'll see an error. So I'll just return it. And then you go ahead and print. So depending on what is passed in for A and B, addition and subtraction. So I'm expecting to see 42 and 10. Yeah, there we go. All right, so that's Lambda functions. Please take time to practice. I've included more links in the description. I hope I didn't lose you. If I did, make a point of going back to local classes and anonymous classes so you can tie it all together to the whys of Lambda expressions. See you in the next one.